Hello, ladies and gentlemen. So we are back, and I have my live studio audience, and I have my at-home audience, and we're now going to talk about two-sided limits. Now, before you move on, I suggest that you stop the video and go back and read your notes and try to figure it out. And because I had my studio audience do that, well, I posted stuff for you, and well, yeah, they had some confusion. And they needed to read it and to clarify ideas. And I got a hint for you. I got a little tip for you. Go explain it to someone else. Force your mom, your dad, your brother, your grandparent, some friend that you don't really like that you can force sit there and listen to you, and explain limits to them. Let them ask questions and force yourself to explain it. You'll learn this so much better. You'll have such a better understanding. You'll figure out how much you don't know so quickly, and it will make it better. So that is a trick I have for you. Whenever you're trying to learn something, the best way to do it, explain it to someone. You can do that. You've got it. And you don't have to study it again. You've got it. All right, so two-sided limits now. A two-sided limit, we need a definition. A two-sided limit is a limit that we consider both directions. We consider as x approaches our a value from the left, and we consider as x approaches our a value from the right. And there is a number line is only two-dimensional, so it's only left and right. There's no up and down. Okay, so there's only two directions that I can approach a on a number line. And so we approach from both directions when we evaluate or compute the limit. So, here's the concept. If, now this is a mathematical logic structure, if both sides of the one-sided limit limits exist, so that's the first thing, they have to exist, and so they have to exist, and they equal the same real number value, and we've been calling that number value L. So as long as both sides of the one-sided limit exists and they equal the same real number value, then, so if those two things are true, then the two-sided limit exists and equals their common value. So this is an if-then statement. Very, very, very important in logic. Okay? So if these two things are true, then the third one is true. If these aren't true, then the third one is not necessarily true. Okay? Notice a couple of things about this. Both one-sided limits must exist for the two-sided limit to exist. Number two, both one-sided limits must equal each other. or the two-sided limit does not exist. Another way to say this is I could have said both one-sided limits must equal each other or the limit doesn't exist as well. So both have to be true. Both side limits must exist for the two-sided limit to exist, and both one-sided limits must equal each other for the two-sided limit to exist. If one of them's not true, the two-sided limit does not exist, period. End of conversation. In math speak, this is what it looks like. If the limit as x approaches a from the left of f of x equals some value L, which equals the limit as x approaches a from the right of f of x, where L is a real number value. So if this is true, then the limit as x approaches a, notice there's no little plus or negative up there. When there's not a plus or negative, it means I'm approaching a from both directions, of f of x exists, and the limit as x approaches a of f of x equals L. That's in math speak. So all of these words up here, I've written down in my language this, and this is the way I'll talk about it from now on. I'll pause the video there and let you copy it down, and then we'll be right back.